Hello, today we're going to take a look at some of the inverse trig functions. The first thing we want to look at is what our inverse trig functions are. Our standard trig functions, let's use cosine as an example. So cosine, the input is going to be an angle measure, so 0, pi over 2, and so on. And cosine will then output a value. For the inverse trig functions, they are going to deal with the same topics, our angles and our values, just going the other way. So cosine inverse, the input is a value, the output is the angle that gives you that value. So for example, we've got something such as the secant inverse of 1. So this is asking the question, where is secant of theta equal to 1? Like, what angle measure will give us that value? In this case, it is going to be at 0. And the thing is, we need to take a look at where our functions are able to be taken in inverse of. So for our functions, sine, tangent, and cosecant, we are using the values negative pi over 2 to positive pi over 2. And for cosine, cotangent, and secant, we're using the values 0 to pi. We need to restrict that domain of our standard trig functions so that the inverse trig functions are functions. It's just like where we're taking x squared and we just look at the positive values when we're taking the inverse, so that the square root of x is a function. So anytime that we have a negative value for sine, tangent, or cosecant, the angle is also going to be negative, even though it is going to be in the location on the unit circle of quadrant 4. It is not going to be like your 5 pi over 3, 7 pi over 4, and 11 pi over 6. It's negative of your standard angles, because that's the section of the graph that we're using to restrict the domain. And then the same thing for cotangent, cosine, and secant, we just use 0 to pi, so anytime that that angle is negative, we're looking in the second quadrant. So let's do a few more of these and how I would approach these, and then look at some compositions of trig functions and inverse trig functions. So cosine inverse of 0, this is looking at where is cosine equal to 0, and this output is going to be an angle of pi over 2. Tangent inverse of 1, where is tangent equal to 1? And that's going to be at pi fourths. Then we take a look at some that are negative. So cosecant inverse of negative 2. What I like to do with this is just ignore the negative for now. And then we find the reference angle and then deal with what quadrant it's going to be in after that. If you're having trouble with cosecant or secant, think about it as the reciprocal. So this is going to be at the same angle measure where sine inverse, the reciprocal of cosecant inverse, has the value of the reciprocal of 2, so 1/2. So where is sine equal to 1/2? All right, well, that's going to be at a reference angle of pi over 6. But since this is a negative 2, for cosecant, sine, and tangent, it is going to be the negative angle. So we're looking at values from negative pi over 2 to positive pi over 2. So all of our negatives are going to be over here with the negative pi over 2. And this is for sine, cosecant, and tangent. For something like secant, so secant inverse of negative square root of 2. Don't worry about the negative just yet, but secant is the reciprocal of cosine. So if you want to look at this as, all right, where is cosine equal to negative, and then what's the reciprocal of square root of 2 is root 2 over 2. This is going to be at a pi over 4, but since it's cosine, we're using values from 0 to pi. And this is for cosine, secant, and cotangent. So the pi over 4 that is in the second quadrant is 3 pi over 4. We can also have some of these where we have a composition of functions. So we have tangent inverse of sine of negative pi over 2. There are some cases where we have tangent inverse of tangent of an angle, or we've got a trig function and its inverse. And that's going to be very similar to, think about the set of inverses that we use the most. So we've got x squared and square root of x. If you take the square root of x squared, those are inverses, so we'll just be left with whatever our argument is. So it could be just negative pi over 6. We have to be careful, though, because it won't always work out that way if our inverse is on the outside. It's the same thing as if we switch the order of these inverses. The square root of x squared, it's not just x, it's the absolute value of x. Like if you take the square root of 16, well, it's 4, but it could also be negative 4. So that's why we need to pay attention to that. So here we want to, if the inverse is on the outside, do it step by step, because sometimes it will work out the same, sometimes it will not. So tangent inverse of sine of negative pi over 2. We want to work from the inside out, just like with any other composition of functions. So sine of negative pi over 2 is going to be negative 1. So our tangent inverse of negative 1, well, we know it's going to be some sort of pi over 4, because that's where tangent is equal to 1, but tangent, we're dealing with negative pi over 2 to positive pi over 2, so it's going to be a negative pi over 4. We take a look at secant inverse of cosine of 0. All right, well, cosine of 0 is going to be 1. So that output of 1 is going to be our input for our inverse trig function. So secant inverse of 1, well, where is secant equal to 1? That is also at the angle of 0. We have ones that go the other way too, where the inverse trig function is on the inside and then the standard trig function is on the outside. We'll look at some in a second. So tangent inverse of, well, tangent of negative pi over 6 is going to be negative square root of 3 over 3. Then tangent inverse of negative square root of 3 over 3, well, we know it's going to be a pi over 6, and since it's tangent, it's going to be negative. So in this case, the tangent and the tangent inverse would essentially cancel each other out, but it will not always happen exactly like that. There are some where we have a value that isn't something that is one of our standard values that would give us an angle. So in this case, we need to draw a triangle. So we have tangent of sine inverse of 4/5. Well, if we're looking at this, we've got a right triangle, we've got some angle theta, which we're looking at. Sine, and we're looking at our basic trigonometry here, so SOHCAHTOA. Sine of theta is opposite divided by hypotenuse. And our output of that is going to be an angle. It's this angle theta. So tangent of theta then, well, tangent's opposite divided by adjacent, so it's opposite divided by, and then use the Pythagorean theorem to find the adjacent. Okay, if we have something where we have cosine of cosine inverse of 7/12, this one is just going to be 7/12. If the trig function is on the outside, they will just always cancel each other out like that. No matter what order you have these in, you work inside out. So if we had something like secant inverse of sine of negative pi over 2, well, we've got secant inverse of negative 1. So where is secant equal to negative 1? That is going to be at pi. there's practice on the OneNote. Thanks for watching, and let me know if you have any questions.